Welcome to Brother Joseph Musonda's YouTube channel. In this video, I'll be explaining to you how we can solve the linear systems of equations in two variables using my own method that I developed. It's not just about the two equations in two variables. Also, my method are extended to those equations in three variables. But for today, let's just have a look at how Musonda's method can be applied to solve the linear equations in two variables. If you look at the Cramer's rule, to solve this type of a problem, I should say, Cramer's rule will require three determinants. There will be three determinants that Cramer's rule would require. But for me, I've simplified that. It only requires two determinants to solve problems of linear equations in two variables. Let's watch and see that. So I'm going to find, first of all, the determinant for x, where I'm going to substitute the coefficients of x with 3 and 8. Then I have the coefficient of y, which is 1, there is a negative 2 here. So this will be equal to 3 times this, negative 6, minus 8 times 1, that is 8, and the result is negative 14. So the determinant for x, that becomes negative 14. Then I'll also find the determinant for y. That will be equal to the coefficient of x here is 3 and 1. Then for y, I need to substitute with the constants. So I have 3 and 8. Now 3 times 8, 24. I'm finding the determinant. Then 1 times 3, that is a 3, equals 24 minus 3, that is a 21. Now how do I find the x value and the y value? With determinants we are done, no need of finding the third one, like Cramer's rule. This one we are done with only those two determinants. So the formula that will be used for finding x will be equal to, if you are using the first equation for finding your solution, it will be C1 multiplied with the determinant of x divided by the coefficient there, which is A1 times determinant of x plus coefficient of y, that is B1 multiplied with the determinant of y. Then for the value of y, it will be, if you are using the same one, if you are using the second, that is C2b, then A2, B2. Since I'm using the first one, that will be equal to C1, then determinant of y. I divide by A1 determinant of x plus our B1 determinant of y. So let's use these two formulas to find the values of x and y. So to start with, x will be equal to, so I'm going to substitute what is my C1, it is a 3, and what is my determinant of x, negative 14, I divide by, then A1, that is a 3. Then just bring this which is on top here, negative 14 should come down here. I don't need the C1. The only thing that makes them to look exactly the same is because the A1 and the constant, they are exactly the same. So plus B1, the coefficient of y from the first equation is 1. Then the determinant of y, it is 21. So that becomes negative 42. We divide by, this is negative 42 plus 21. That is 42 divided by negative 21. In fact, there is a sign that I forgot here. We need to have a negative. When we divide that, our x value is positive 2. We go to y, We substitute once again, and our C1 is simply 3, and dy, that is 21, I divide by what I have here, 3, negative 14, plus 1, and 21, because you can see the denominator here is the same. This will be equal to, on top 3 times that, 63. Remember what we got here, negative 21. And the result here is negative 3. So the answer, x over y, will be equal to 2 over negative 3. Thanks for watching. It all ends here.